Honors Pre-Calculus students, welcome to today's lesson. This is section 4.1. It's our introduction to trigonometry, a subject which you already know and love. Today we're starting with some basics with radian and degree measure. To start with some reminders, you can see them here. Conversions, when we convert degrees to radians, we take our degree measure, multiply by pi, divide by 180. Whereas if we're going the opposite direction from radians to degrees, we take the measurement in radians and multiply by 180 degrees and divide by pi, the reciprocal of the process of degrees to radians. Another thing to remember, coterminal angles have the same terminal or ending side. The key here is that they differ by 360 degrees, or if you're working in radians, it would be 2 pi radians. So let's start with a little conversion, 240 degrees. We're in degrees. We will simply multiply by pi, divide by 180 degrees. And I'm going to kind of do this in one step. 240 divided by 180 is 4/3. What I have here is 4/3 pi. Number 2 is written in radians. So to convert this one, we'll multiply by 180 degrees and divide by pi. Now what happens is the pi's will cancel, and so what we're left with is just simply -3/5 times 180 degrees, and that would give us -108 degrees. It's that simple. Conversion. Alright, let's sketch some angles. So our first problem here asks us to sketch the angle -12 pi over 7. A couple things to keep in mind. Negative suggests to us that we need to go in the clockwise direction. And 12 pi over 7 tells us that we're talking about less than a full circle, less than 2 pi radians. So what I would look at, and I'm going to grab a little line here. If we started directly out this way, that's 0 radians. And as I work back this way, that's -pi over 2, -pi. This, if I went all the way back to my starting point, would be -2 pi, or -14 pi over 7. So we're 2/7 pi short of that. So we're going to be somewhere in this first quadrant. And if I want to show that this was moving in the negative direction, I can just simply draw a little arrow that goes around like this to show. Alright, our next one, it's a weird looking angle, 5. There's no degree symbol, so it's implied that we're measuring in radians. Now, what I would suggest is thinking about this in terms of, well, how many radians is pi, or is 2 pi? So when you think about it, we've got 0 here. This is pi radians over here, and pi, remember, is like about 3.14. So pi over 2, half of that would be 1.57. Down here is 3 pi over 2. I could just add these two numbers together, so this would be about 4.71 radians. And if I went all the way back to 0, this would be 6.28. All those numbers are, of course, approximate. And you can see then, when you think of the circle that way, that finding 5 radians wouldn't be so tough. I'm at 0 up to 1.57, 3.14. Down here we're at 4.71. We just need to go a little bit further, and it is just an estimate, of course, but somewhere right around there would be 5 radians. Okay, some more reminders and a little practice with this. Supplements and complements. Remember, supplements means two angles whose sum is 180 degrees, where complements have a sum of 90 degrees. So if we looked at 74 degrees, if I want to find the supplement, I would say 74 degrees plus my unknown, I can call it an x, would equal 180. So my supplement would be 180 minus 74, or just simply 106 degrees. For the complement, I'm just looking at the difference between 74 and 90. I don't expect that you'll typically write this out, but if you'd like to, it's definitely fine. So our complement here is 16 degrees. For number 6, we're going to go through a similar process, but you'll notice that this angle measure is given to us in radians rather than degrees. So when I want to find the supplement of 2 pi over 5, I would have to take pi and subtract 2 pi over 5. Now we'd have to obviously get a common denominator, and that would give us a supplement of 3 pi over 5. Now for the complement, we have to think, okay, not 90 degrees, but pi over 2 radians. And again, we need to come up with a common denominator, and in this case that would be 10, so I'm going to make this 5 pi over 10 and make this 4 pi over 10, and what I'm left with is a complement of pi over 10. In this particular problem, both those are measured in radians, of course. You don't have to actually write the word radians. It's implied when there's no degree symbol. All right, next two examples, coterminal angles. If you remember back to what we saw on the first slide, it says coterminals are angles that have the same terminal or ending side. The key there, they have a difference of 360 degrees or 2 pi radians. So this says I need to find two coterminals, one that's positive and one that's negative. I'll start with the positive version here. We're going to add 360 degrees. That's a coterminal angle, and it's positive. Same idea, opposite direction, we're subtracting 360 this time, and we would get negative 311 degrees. Now for number 8, this time again it's in radians. The first thing I noticed though is the angle that's given to us, 16 pi over 7, it's already more than 2 pi. So if I were to subtract 2 pi, or 14 pi over 7, I would get a positive coterminal angle. So if I need to get a negative coterminal, I'm just going to take that 2 pi over 7 and subtract 2 pi again. So now I'll have a negative coterminal angle to 16 pi over 7. That's essentially 2 laps around the circle. Okay, the next topic we're going to look at is DMS, also known as degrees, minutes, and seconds. And you can see an example we have here, 53.5 degrees is equivalent to 53 degrees and 30 minutes. Just like when we measure time, there would be 60 seconds equals 1 minute. And then with time measurements, we say 60 minutes equals 1 hour. Here we say 60 minutes equals 1 degree. All right, so when we want to convert, the way we do this, essentially it's one step at a time. So number 9 says to convert to DMS. I know it's 15 degrees. Now I need to find minutes and seconds. So I'm going to take 0.73 times 60. That gives me 43.8. That 43 right there would represent the number of minutes. The 0.8, if I multiply that by 60, that's going to give me the number of seconds. So 15.73 degrees is the same as 15 degrees, 43 minutes, and 48 seconds. Why don't you guys give number 10 a shot on your own? Okay, so I finished number 10. You can see I got negative 29 degrees, 28 minutes, and 30 seconds. All right, let's work at going the opposite direction. And when I see a problem like number 11, 37 degrees and 53 minutes, that's the same as saying 37 degrees plus 53 sixtieths of a degree is the way I would think about it. Now 53 sixtieths is about 0.883, so I'm going to go ahead and just write this as 37.883 degrees. Why don't you pause this, try number 12, see if you can figure out what to do on 12 and then start this video back up. Okay, as you can see I finished number 12. Notice what I did with the seconds. There are other ways to approach this problem that you may have figured out that may be great, but 1 second would essentially be 1/3600th of a minute in time, or in this case we're in degrees, so 1/3600th of a degree. So 15 seconds would be 15 over 3600 degrees. And I simply punched those numbers into the calculator and rounded them off. All right, let's take a look at our last slide. Two topics that you've actually seen before, although perhaps not exactly written like this. The first one is arc length. You can see the formula is S equals R theta. And then sector area is equal to 1/2 the radius squared times theta. Now when I look at number 13, it's telling me to find the central angle. The formula here is S equals R theta. I actually in this case know the arc length to be 7, the radius is 4, and theta is what I'm trying to find. A quick step of division and I've got my central angle. It's 7/4. And I'm just going to leave it that way. That's a measurement in radians. Why don't you guys pause the video and do number 14 on your own. As you can see on my example, theta is 25/7. I've gone through and used the S equals R theta arc length formula, and hopefully that's the same thing you found. Again, we could change these into degrees, but there's nothing in the problem that says that we have to do that. So in some ways it makes sense just to keep it simple. Okay, on number 15, we're asked to find the sector area. One thing to consider on 15A, you'll notice that our angle theta is given to us in degrees. In order to use the sector area formula, we actually have to convert this into radians. So that theta, whether it's arc length or sector area, always has to be in terms of radians. So now I can use my sector area formula, 1/2 times the radius squared times 7 pi over 6, our central angle. And when we go through and do the multiplication there, we get 21 pi is what I'm seeing, 21 pi square meters. Why don't you guys do number 15B on your own? So pause the video and work through that. You'll notice on 15B that the problem was actually given to us in a little bit simpler form, since we already knew our angle was 7 pi over 5 radians. And you can see I got 70 pi square feet is the total area there. Due to time constraints, I'm going to have to put number 16 on a separate video. So you can just look at part 2 of this lesson and I'll walk you through that problem.